We're going to start by thinking about some relationships between sine, cosine, and tangent and cotangent. This is something you learned in grade 11, and I hope you learned why. I hope you've seen this before, but you might not have. Oh, and this is a really nice little intro, very simple, but for when we start identities in the next unit. So there will be some identity review. That will be like grade 11 identity stuff that we'll do early in the unit. And then I would encourage you to kind of work through some of it. If you find identities hard, it takes time. So you'll have to work through that. But there'll be some review to do early on. And then we do some other grade 12 stuff. And then at the end of that unit, we'll do like 3 days or so of identities of our own, like grade 12 identity work, okay, before the test. So that's for the next unit. So this is like our first little refresher of identity stuff. Okay, so you probably know and you remember this is called one of the quotient identities. That tangent, oh, no, sorry, that's not it. That tangent is equal to sine theta over cosine theta, right? That's one of the identities you learn in grade 11. But why? Why is that true? We can prove it. I mean, it's true because it's true. But, like, do we just take it for granted that it's true? So here's what I'm going to do. Left side equals tan theta, and right side equals sine theta over cosine theta. This is a little bit of an abnormal identity proof because we don't usually use SOHCAHTOA as part of the proof. But again, this is just like a little mini thing. It's a nice little intro to what we'll do next unit, and it reminds us of some important details about tangent, cotangent, that kind of thing. So another way that I can write tangent is opposite over adjacent. And how can I do the same thing? Because we always work on the left side and the right side separately with identities, right? So we keep them separate. We don't move things around the equal sign or anything like that. Okay, so sine theta is opposite over hypotenuse. And cosine theta is adjacent over hypotenuse. And so how can I simplify this? Well, this is the same thing as opposite over hypotenuse. If I'm dividing by adjacent over hypotenuse, I can multiply by hypotenuse over adjacent. And lo and behold, opposite over adjacent, which equals the left side. Awesome. We're done. Okay, and so one of the things you're going to do, not right now, but that I'm going to encourage you to do in a moment, is the same thing for cotangent. It's the exact same thing, really, but it gets us used to thinking about reciprocals and that sort of thing, and working with the stuff. And like I say, a little bit of a warm-up for when we start identities in the next unit. Okay, the next thing we're going to do before, the triangles. Okay. So what we want to do, let's go ahead and label these because we're going to need them again. So I'm going to let you try that on your own. Just sketch them out. If on that learning goal you did the special triangles wrong, my goodness, like find a way that works for you to get those things in the right place. When we looked at this the first couple times around, and I showed you how this special triangle on the left here comes from the equilateral triangle. So if you know that, that's supposed to help me know where the 1, the 2, and the root 3 go. Think about the size of those. The square root of 3 is less than 2 because the square root of 4 is 2. The square root of a smaller number is smaller, right? Okay, and this one's pi by 4, pi by 4. This is our isosceles triangle, and 1, 1 by Pythagorean theorem, square root of 2. So there's those two things. You're going to need those. So if you've got them copied down, here's what we're going to do. We're going to answer a couple of questions, but first, before we do that, we're going to fill out a table. So you're going to do this in your notes, and this is what the table looks like. It is big, yes. I'm going to show you how this table works in a minute. Oh, there's a mistake here. This should be 0. There should be a column with a 0 in there. One extra column before it starts pi by 12. Well, it goes up to 24 pi by 12, so like 25. Do your best to fit it on the page. Okay, folks, put your pencil down and watch carefully because I just want you to understand what it is you're doing. And this is probably going to take most of the rest of the period. There's not a lot of homework tonight, so it's simple, I think. So this is 0 pi by 12, 1 pi by 12, 2 pi by 12, 3 pi by 12, 4 pi by 12, but put those simplified in the box, 5 pi by 12, and so on and so forth, right? So this one's actually 5 pi by 12. 2 pi by 12 is the same as pi by 6. And so then what you're going to do is pi by 6. So what is the cos of pi by 6? Go back up to your special triangle and figure out the cosine of pi by 6. So it's adjacent over hypotenuse, root 3 over 2, and then you put that in the box, root 3 over 2. Okay, and you got to figure out whether it's positive or negative. This is great review for, you'll see some patterns and you can start to kind of cheat, but great review for angles in standard position as well, thinking about casts and that kind of stuff. This one's just going to be blank. The pi by 12, you don't need to do that one. Okay, we're just doing some of them. You don't need to do all of them. Do as many as you can. Same with 5 pi by 12. That one's going to be blank. Does that make sense? Because that's just where we're going to start. So you want to have a column for 0. It should be in mine. It's just not. But for example, what is the cosine of 0? What's the sine of 0? What's the tangent of 0? What's the cotangent of 0? What's secant of 0? What's cosine? But that's what we're trying to figure out. Okay? Okay, so I'm going to give you a good chunk of time to get some of that started. You won't get it all done. Try to get at least at least cosine and sine done, or mostly done. And I'll give you maybe 10 or 15 minutes, and then we're going to do some stuff with it, but you want to have it done first. Along with the special triangles, I think about this as well. So for cosine, it's here. So this is 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. So what is cosine at 0? It's 1. I know that from the graph. What's cosine of pi by 2? 0. What's cosine of pi? Negative 1. 3 pi by 2, 0. 2 pi, 1. So instead of using special triangles or even angles in standard position, thinking about the radial arm, I use the graph. And I think it's the easiest way. That's what I would recommend you do. And so same thing for sine. Sine of 0 is 0 because sine starts on the 0 line, starts at 0. Like, you know that. You can graph that. You know that super easy. Okay? And so sine of pi by 2 is 1. Sine of pi is 0. You could plug it into your calculator too, of course, right? And get some of those. If it gives you a nice round answer, you can cheat and use your calculator, but it's better if you think about it. Sine of 3 pi by 2 is negative 1. Sine of 2 pi is 0. Okay, so here's the finished version. Yeah. Here's where we need to start thinking about, here's where today's thinking starts. What did we learn in the beginning? Tangent is sine over cosine. So tangent of 0 is 0 over 1, which is 0. tangent of pi by 4 is root 2 over 2 over root 2 over 2, which is 1. Like, we already know that because we can use the special triangles for tangents as well. But I can think about it as a quotient here. When I get here, this is like the second quadrant. So cosine is negative, right? So tangent is a positive over a negative, which is negative. But we also know that tangent is negative in the second one. They're all negative, but why are they all negative, right? And again, this relates back to like cirtics as well, the x and the y and the r and all that stuff is all different ways of looking at the same stuff. Okay, and I can figure all of these out. So why is this one undefined? Because 1 over 0 doesn't work. Does that make sense? So this is how you're going to fill out the rest of this. There's a lot of information here. Like, what is this? 2 root 3 over 3. That's just the simplified version of root 3 over 2. And I took the reciprocal because the reciprocal of cosine is secant. So I flipped it and then I rationalized the denominator. I multiplied by root 3 over root 3. Gave me the root 3 on top, so 2 root 3 over 3. Don't be confused by that. If you didn't quite follow it, that's not a big part of this, but you should be able to rationalize the denominator. Okay, so that's all of that done, right? Cosine at pi by 3 is a half. So secant of pi by 3 is 2. I mean, you've done this already, right? But using this table, I can easily come up with all the other reciprocals. Cotangent is the reciprocal of tangent, so I take that and I flip it, right? So 1 and 1, root 3 and root 3. Everybody good with that? We're going to do one more thing with this, so you need to kind of be seeing this first before we move on. Okay. Now, how would I graph? What are we going to graph first here? What do I want to graph first? Tangent. How would I graph tangent? It's sine over cosine. Where will the graph tangent start? Do you remember in the last unit? Are you waiting for me to talk, or do you not, or you don't know? That's okay. Remember in the last unit when we did reciprocals of functions and we did quotients of functions? When is there an x-intercept? When the numerator is 0. Tan is sine over cosine. When is there an asymptote? When the denominator is 0. Tan is sine over cosine. Cosine is your denominator. So when I'm making my graph of tangent, I'm going to think about the graph of sine and cosine and use all my skills from the last unit to come up with it. Because you're about to learn 4 new graphs. And they're strange. And they're all kind of like each other, but they're all different. And you need to know which is which. And how do you do that? Just by going back to all that stuff we know from the last unit. Right? So if this is 0 over 1, tangent is going to be 0. What else do I know? This is something over itself. It's where sine and cosine meet. It's where they are the same. Something over itself is 1. This, sine is the red curve. So sine over cosine is 1 over 0. There's an asymptote. Okay, and you can go back and do these a little bit more closely for all of the different graphs, all of the different functions, and you can see that it's going to be something like that, and then we're going to figure out what happens next. Okay, but hold on, I'm going to show you a different kind of demonstration. I'll put these online too in case you want to look at them. I think this one's tangent. So there's sine, starts at 0. There's cosine, starts at 1. And as I drag it, there's tangent. So look at how tangent is the black line here. I don't know if you can see it. It starts at 0. When they are equal to each other, tangent is 1. And then it asymptotes. And then it's negative. Why is it negative? Because cosine is negative. Sine over cosine is negative, right? Positive over negative. And then watch when cosine becomes 0 again, another asymptote. And then it repeats. So there's the graph of tangent. How could you now you need to know that. I might ask you to graph tangent on the test. How could you do that? By thinking about sine over cosine and where asymptotes and x-intercepts and ones occur. That should be something that you're capable of doing. Okay? So what would cotangent be? So I'm going to let you do this on your own. You're going to use that table that you created to come up with your own graph of tangent, cotangent, secant, and cosecant. That's part of your homework tonight. And then if you want to see the answers or if you want to talk about it tomorrow, we can do that. Okay? So what would cotangent look like? Remember, cotangent is cosine over sine, so it's going to be very similar, but it's going to be the other way around. When tangent has an x-intercept, cotangent will have an asymptote. Cotangent is also the reciprocal of tangent. When tangent has an asymptote, cotangent will have an x-intercept. Folks, I don't know, I think this would be really hard if you don't spend some time thinking about quotients and reciprocals and thinking about like asymptotes like we did in the last unit. Okay? Any questions about that? Let me keep going. Here's secant. Secant is the reciprocal of cosine. So if cosine starts at 1, where will secant start? Hunter?
1.
At 1. What's the reciprocal of 1? 1. See what I'm saying? This is something we're supposed to know. Remember on the test, I always told you the graphs will meet at 1. So let's see what happens with secant. There it is. And look, cosine's getting smaller, so the reciprocal is getting bigger. And what does cosine do first? It goes to 0, and so now I have an asymptote. And then cosine approaches -1, so secant approaches -1, but from below, because this is cosine is very small. So 1 over a small number is a big number, but negative. Here's something that people made mistakes on in the last unit. The reciprocal of a graph will always be negative when its graph is negative, right? Like if a graph is below the x-axis, the reciprocal can't be above. How could that happen? The reciprocal doesn't change whether a function is positive or negative. Okay, so they meet at -1 at pi. We know that from the parent graph of cosine. And then cosine goes back to 0, so look, it approaches the asymptote. And then they meet at 1, asymptote, meet at -1, asymptote. So there's what secant looks like. I'm going to go back to 2 pi. That's 1 full cycle of secant. It looks like a bunch of u's and n's. That's fairly easy to remember. If you work with this a little bit, graph it a couple times, it's pretty easy to remember, well, one of them does this and does this and does this and does this. But the trick is knowing which one is which, I think. Tangent does this, whoop, 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 right? And if you can figure out which one's which by thinking about reciprocals. Okay, one more. Cosecant. Sine starts at 0. So where will cosecant start? No? What's the reciprocal of 0?
It would be an asymptote.
At an asymptote. If you were thinking an asymptote, good for you. Cosecant starts at an asymptote. They meet at 1. Sine goes back to 0, so another asymptote. Another asymptote. Another asymptote. Every time sine goes through 0, cosecant is an asymptote. There's one cycle. Yeah. Any questions? Clear as day, right? Listen carefully. I think a lot of people avoid going through the necessary thinking for these reciprocal graphs and quotient graphs. Tangent, cotangent, secant, and cosecant. It's not that bad once you connect it to the graph it's a reciprocal of. Once you start thinking about x-intercepts and asymptotes, it's not bad, and you can work with it and figure it out. The next part of the lesson is, I think this is supposed to be for tangent. Where is the first x-intercept of tangent? Where's the next one? Before you answer that question, when does an x-intercept happen for tangent? Why is there an x-intercept for tangent? Like, what makes it an x-intercept? Sine is 0. So if you can graph the parent function, you can figure, and you understand that sine is the numerator of tangent. You can find where sine is 0 fairly easily and find the x-intercepts. First one happens at 0, next one happens at pi. You can figure out where they are. That's not right. Okay. What about, what was I going to say? Asymptotes. Oh, what's the distance between them? You can think about that. What about asymptotes? Where's the first asymptote of tan? I'm just going to let you think about that. You have to go through the thinking and figure that out. Where's the first asymptote of tan? And why? Cosine, where cosine is 0, so where does that happen? So you want to think about that kind of for every graph as you're looking at it. You want to think about the period of each of those, because they're not all quite obvious or the same. The questions in the textbook ask you about that. So trust me, you want to think about these things. What's the period for tangent, cotangent? Some of the questions in the homework ask you to answer in a weird way, like write in a relationship for when the x-intercepts happen. You don't have to do that, but what you need to think about is where's the first one, where's the next one, like after how far does each next x-intercept or asymptote occur.